Hello guys, we are looking at another problem on the sine and cosine rules. So those are the sine and cosine rule picked from your triangle. The main thing is to know your conditions. You see all three sides is cosine rule, two sides included angle is sine rule. If not, two side included angle is still cosine rule. If these two conditions are not valid, go straight to the sine rule. So that is a diagram. I told to calculate angle ABC. So when it is written like this, it means the need angle B, in triangle ABC. So the first thing I will do is I look at the original diagram, I cut off the triangle ABC. So if I cut off my triangle ABC, my triangle looks like this. Then I've got my A, angle 43. I've got my B there, I've got my C, this is 36 degrees, then the side AC is 2000. So they need angle B. So that is what they are looking for. So you know that the sum of the interior angles of the triangle is 180. So I'll simply say angle B is 180 minus 43 minus 36. Then I'll see my angle B. So I'll do that with my calculator. 180 minus 43 minus 36, so it tells me that my angle B is 101. So you can either call it angle B, or if you can use angle A, B, C, making sure that the person you are targeting is in the middle. So if you write like this or like this, you are saying the same thing. So we are done with A, let's now look at B. B says calculate DE. So if you look at original diagram, you see where DE is. You can see that it looks a bit interesting. They need DE. So if you are to calculate DE, you need to cut off a triangle that has DE. Which if I cut it off, I will see something like this. From my original diagram, I will see the D there, I see E there, I see F. This is 90, this is 27. But with this triangle, there is really very little you can do because you don't know any side. So you need to check from the other side. Now, looking at the original diagram, I can see that the side they call DF is the same thing as the side they call BC. So that's what you see from your original diagram, that DF is equal to BC. Where do I get BC? In the first triangle. Triangle ABC. So for me to solve this triangle, I must go back to that one, calculate BC, which will be the same thing as DF, as I see in the original diagram, then I can move on. So now, to calculate BC, I now know that in the triangle ABC, this is 101, then I know only one side, so that means three sides I don't know, two sides I don't know, I can never use the cosine rule. Then it is not, there is no angle 90, I cannot use Sakatua, which is level 2 trigonometry. So I must only go to the sine rule. There is no way I can use cosine rule because I don't know two sides, I don't know three sides. So if I go there to state my sine rule, I must be looking at my triangle. My sine rule will be stated to look like the sine rule there, but you must understand that with the sine rule, angle A is opposite to the side A, as you see in the triangle. They must face one another, they must be looking at one another. Angle B is opposite to side B. So I'll do the same thing here. So since I'm looking for the side BC, it means I'll be saying the sine of angle A over the side BC that I'm looking for. I must confirm that they are facing one another in my triangle. Then it's equal to the sine of angle B over the side AC. So I'm targeting the side AC because I know it, and I now know angle AB. So if I substitute my information in that, I'll be seeing that sine A is 43, BC, I'm looking for you, angle B is 101, AC is 2000. So from there, if I cross multiply, I'll see that BC multiplies sine 101 is equal to 2000 is multiplying sine 43. Then BC should be 2000 sine 43 on sine 101. manipulate that on my calculator. So I get 2000 sine 43 divided by sine 101. So that gives me my BC. My BC will be 1389,526 meters. So BC is obviously going to be now equal to DF in my triangle there. So my BC is equal to DF. So if I now come to this triangle, I know that I've got this side as 1389,526. That is what will permit me to look for DF. So luckily, this is a right angle triangle. So if I need DF, I'm free to use Socatoire, my level 2 trigonometry. So I'm free now to use this one. So DF is the hypotenuse. So I can say cos 27 is adjacent on hypotenuse. Then I'll go for so cos 27 degrees is equal to adjacent. My adjacent is my 1389,526. My hypotenuse, which is DE. Then if I cross multiply, I'll get DE cos 27 is equal to 1389,526. Then I divide both sides by cos 27. That should be able to take me to DC. So I'm dividing this by cos 27. And that tells me that my DE is 1559,502. So that's how you get DE in that problem. So apply the sine rule with a bit of trigonometry. So we are now going to look at this one as well. This is another diagram. We need CT. So the story stays the same. I go to my diagram, I cut off a triangle that contains CT. So the best triangle will be CBT. So I must cut off a triangle with a lot of information. So if I cut off triangle CBT, in my diagram, I'm seeing something that looks of this nature. There is C there, there is T there, there is B there. This angle we are told is 60 degrees. Then this side is 40 meters, and this side is 80 meters. So looking at it, you see that I've got two sides, BC and TB. Then the included angle, that's a condition for the cosine rule. So I can now state my cosine rule, which will help me get CT. So when I'm stating my cosine rule, I start with the side I'm looking for, and with the angle, looking at CT face to face in my triangle. So you must always generate your rules from your own triangle. So I'll say CT squared is equal to CB squared plus TB squared minus 2CB times TB, then the cos of angle B. Then I start substituting CB of 40 squared plus 80 squared minus 2 into 40 into 80, the cos of angle 60. So I should finish stating, always compare that these two are looking at one another face to face in your triangle. If you don't confirm that, your rule might look like the cosine rule, but the solutions from it will be wrong. So now I do my calculations. 40 squared plus 80 squared minus 2 times 40 times 80 times 80, then times the cos of 60. So that gives me 4,800 plus CT squared. Then from there I can get CT, taking the square root of 4,800. So the square root of 4,800 gives me 69,282 meters. So that is the A part. You can then look at the last part. We need the height of the tower FT. So if I go back to the diagram, FT is here. So I can cut off triangle FCT from the original diagram. So triangle FCT, luckily it looks like a right angled triangle where we've got our F there, and 90 there, C is there, this angle is 40 degrees, then T is there. So we've calculated the CT to be 69,282. So we're now looking for FT. So if I'm looking for FT, I can use Zacatua sine is opposite over hypotenuse. So this will tell me that sine 40 degrees is equal to opposite, that is FT, over hypotenuse, which is 69,282. Then I cross multiply, my FT will be 69,282 sine 40. Then I talk to my calculator. So I'll multiply my answer by sine 40. And that gives me 44,534 meters. And that is my FT. So guys, that's basically how the sine and cosine rules work out. Thank you very much.